Welcome back, everybody. We're going to look at one new postulate and three new theorems today. These are the converses of a postulate that we had earlier and the converses of three theorems that we had earlier. Okay, so the postulate, remember, you don't prove. And so I'm just going to read that to you, and we're going to look at a little diagram to kind of think about what it means. Our first postulate says, if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So all four of these theorems today are how to prove lines parallel. We're not starting with the lines parallel. We are proving that they're going to be parallel. So this postulate, which is accepted without proof, I put a little picture diagram in instead of a proof. But it says this: if you got two lines, notice we didn't say two parallel lines, but if you got two lines that are cut by a transversal and corresponding angles are congruent, then the lines are parallel. That's the conclusion. So it's exactly the converse of what we had earlier. So we're going to use this converse to prove the theorems in this unit here, in this topic. Okay, so that's our first postulate here. Okay, so first theorem out of three here today. So this theorem says, if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. So again, we're doing the exact converse of what we did earlier. We're saying this time if we have two lines, any two lines that are cut by a transversal, and if in that process you have alternate interior angles being congruent, the conclusion is then the lines are parallel. So in my little diagram here, we have line M and N that are cut by the transversal, and we're given that angle 1 is congruent to angle 2. That follows the hypothesis there, that follows the if. And we are trying to prove that line M and line N are parallel. Okay, so we know the drill on the proofs. Now we're going to recopy that given and then write given. So we're given in this diagram that angle 1 is congruent to angle 2, and so we write given for the reason. Okay, so remember, our last statement is going to be that line M is parallel to line N. That's what we're trying to prove, so that'll be our last statement. Okay, so if you look at the diagram, we can also make a statement that angle 1 is congruent to angle 3. If you look at those two angles, those are vertical angles, and we know from a previous theorem that vertical angles are congruent. So that's our reason for statement number 2. Vertical angles are congruent. Now, if you take these two statements together, and we do this a lot as you've seen so far this year, if you take those two statements together, angle 2 is congruent to angle 1, angle 1 is congruent to angle 3, so that means angle 2 must be congruent to angle 3 by the transitive property. So now we've got angle 2 congruent to angle 3. Well, look back up at your drawing. Look at angles 2 and 3. Those are corresponding angles. So now we're going to use a postulate that we had at the start of the hour to prove our statement. So now we can conclude that line M is parallel to line N because if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. We satisfied the hypothesis. We showed that two lines cut by transversal, we showed that the corresponding angles are congruent. So the conclusion is then the lines are parallel. And so we have proven our theorem. If two lines are cut by transversal and alternate interior angles are congruent, then the lines are parallel. The other two proofs are going to be similar to this one. Okay, next theorem. If two lines are cut by transversal and alternate exterior angles are congruent, then the lines are parallel. So look at the diagram that I have here and look at what we have given and what we're trying to prove. So we're given that angle 3 is congruent to angle 4. That's the alternate exterior angles that are given to us to be congruent. What are we trying to do? We're trying to prove that line M is parallel to line N. Remember, that's the conclusion to the theorem. That's the then part. So the given is the if, and what you're trying to prove is the then. Okay, now keeping an eye on that drawing as we go through the proof. Angle 3 is congruent to angle 4. That's given. Right, that's part of the if. Alternate exterior angles are congruent. It's part of the given. Look again at angle 3 is congruent to angle 5. We know that from the previous proof that vertical angles are congruent, so we can say that. So you can see how similar this proof is to the previous one. Again, take these two statements taken together. Angle 4 is congruent to angle 3. Angle 3 in turn is congruent to angle 5, so that means that angle 4 is congruent to angle 5 by the transitive property. Now, again, look at your diagram. We now know that angle 4 is congruent to angle 5. Those are corresponding angles. So we now have shown that two lines are cut by a transversal. We've shown that corresponding angles are congruent. Our conclusion is the lines are parallel. So that's our last statement and our last reason. Line M is parallel to line N because if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So those proofs are almost identical. Okay, we have one more proof. That'll make our last proof of the day here. This theorem is the converse of one that we had earlier in the course. This theorem says if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. Do you see how that's the converse of what the one we did earlier? Earlier we said if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Now it's exactly the converse, which is why we did that whole unit 2. So again, the theorem we're trying to prove is if two lines are cut by a transversal and same side interior angles are supplementary, the conclusion is then the lines are parallel. So notice all 4 conclusions today in the same way. Then the lines are parallel. So there's your diagram. Now what are we given? We're given that same side interior angles are supplementary. So regarding this drawing, we're given that angle 5 and angle 6 are supplementary. So that's in your given there. What are we trying to prove? We're trying to prove that those two lines are parallel. That's the conclusion of our theorem. Okay, let's do the routine. Statement number 1, angle 5 is supplementary to angle 6. That's given. You can see it there. Statement number 2, angle 5 is supplementary to angle 7. Look at that. That's a linear pair. And our very first theorem of the year said that if two angles form a linear pair, then they are supplementary. So we now know that angle 5 and angle 7 are supplementary by the linear pair theorem. Okay, again, take these two statements together, right here, statement 1 and statement 2. Consider them together. Think about this. You got angle 6 supplementary with angle 5, and you have angle 7 supplementary with angle 5. So our statement is going to be angle 6 is congruent to angle 7. We have a theorem for that. It's called the congruent supplements theorem. And just to restate it, what it says, if two angles are supplements to the same angle, then they are congruent. So that's a perfect place for the congruent supplements theorem. If two angles are supplements at the same angle, then they're congruent to each other. Okay, so now we got angle 6 congruent to angle 7 by that theorem. Look back at your diagram. We got angle 6 and angle 7 congruent. Now we're going to use that first postulate of the day to prove those lines parallel. So that's our last statement. Line M is parallel to line N because if two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel. So if you look at what we did, we used that first postulate today to prove 3 new theorems. So let me summarize these. I don't have any examples for you today, so we'll just use our assignment as our practice problems. But what we need to know today is this. First of all, the postulate. If two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel. So we know that. That's a postulate. Then we had 3 theorems. If two lines are cut by transversal and alternate interior angles are congruent, then we also know that the lines are parallel. That's also the converse of a theorem we had earlier in the year. Look at our next theorem. If two lines are cut by transversal and alternate exterior angles are congruent, then the lines are parallel. So that's the third way we know lines are parallel. And the one we just had, if two lines are cut by transversal and same side interior angles are supplementary, then the lines are parallel. So we have 4 ways to prove lines parallel, which are exactly 4 converses of what we use to prove angles congruent or supplementary. So now these are the converses. These are all 4 used to prove lines parallel. Okay, so the video is up on Google Classroom if you need to see it again. But now let's take a look at some example problems so we can get some practice with these theorems. All right.